Hey everyone, what you can see here is the very start of my next project. It is an Arduino controlled, hand-programmed XY stepper laser scanner. I only have the Y-axis right now, and as you can tell right here, it is working pretty good. The reason why it looks like it's a bit of a curved arc there is because the alignment is just kind of held together. It's a little handheld pointing onto the Y scanner mirror. But I just wanted to throw something up together real quick so I could test the code and work on any bugs. My first bug was that the first two output pins on the Arduino here are required for updating the Arduino, which I forgot, and I spent a good hour and a half trying to figure out why it wouldn't push any code. At first I thought the code wasn't working, and then I realized it wasn't pushing the code, and it's because I was using those pins. So I shifted everything up to, and it's working fine now. I can adjust the speed and change the program and all that. I'll turn off the laser and spin it around for you to see in a second, but the circuit's real simple. It's just a 1N914 diode in parallel, anti-parallel with each winding. It's basically a flyback diode to protect the circuitry. And I'm using PN2222A, I think it is, NPN transistors just for signal switching, because the Arduino can only sync or source 40 milliamps, and we're running about 85, 90 milliamps there on average. So, and the voltage doesn't seem to be too critical. This is a 12-volt stepper, but I don't need to run it that fast. I don't see any benefit over about 7 volts, and that's just because the voltage drop from running bipolar instead of MOSFET. I don't have a lot of MOSFETs around. I happen to have 10 or so of the 2N222s. So here, let me turn off the laser, and I'll move it first. And turn around the stepper motors so you can see it in action. Just have it running 8 steps up, 8 steps down. Or was it 16 steps up, 16 steps down? 16 and 16, 32 total. And maybe tomorrow when I get a chance I'll finish wiring up the other side there. And then it's programming for like frickin' ever. The code's not that bad since a friend of mine introduced me to subroutines. Now I knew what subroutines were, I just didn't know how to do them. And it's not that bad. But even so, I mean, here's one subroutine. It starts there. That's the end of it. That's a single one of those. I need 64 subroutines. 32 for X, 32 for Y. So it's going to take some time. I did, however, get it all, the initial hurdle fixed. I'm using delay microseconds here because it gives me a bit finer control. And I first used delay straight, which is milliseconds. But I didn't have fine enough control on it because you can't really do 3.5, milliseconds. You can, but it's not very accurate, and I wanted fine control, especially for the off time, and be able to really adjust the off time to nice and short, because it doesn't really benefit you at all to have a longer off time. I think theoretically you could run with no off time, because it would just reduce the bright spots where it pauses, but I wanted to have the option in there, so I used it to change it to delay microseconds. I think I have 3 subroutines written so far. Yeah. I have a 16-step, a 15-step, and reverse 16-step. Woo. 62 more to go? I think 60, 61 more, something like that. Shit ton anyway. But that's the program for now. And hey, it's working, so I can't complain. I mean, you could spend like 20 bucks on a stepper motor controller, or you could just do it, which is not hard. You need 1 transistor and 1 diode per coil. That's not bad. Thanks for watching, and hopefully tune in again soon for an update.